Hey guys, in this video we're going to cover activity 8C.3. Our mastery learning objective is I can find the length of an arc by setting up a proportion comparing the arc to the circumference of the circle. So the first couple things that we need to identify are a couple vocab words. One of them is arc measure. Our arc measure is going to be an angle measure of the arc, and this uses degrees as a unit. So what we're going to do is try to write first off the angle measure of the arc. And this uses degrees as a unit. All right, so this is going to be, again, our arc measure. Our arc length is the distance of the arc. So this is the distance of the arc. And this is typically measured in some type of unit of measure. So it uses either feet, meters, centimeters, something that you're measuring distance with. So it could go on and on and on. And that's how you know the difference between an arc measure. That's going to be a degree. And arc length is going to be a certain a unit of distance. So this formula that we have down here is going to be what we're going to reference to figure out what our arc length is. So if you look at this formula, our arc length is equal to the arc measure divided by 360 times the circumference. Now there's a couple of things I need you to change because they're not on here. So the first thing would be if your arc measure is in degree mode. So up here, we know we're going to be using degrees. Then you're always going to divide by 360 because that is the angle measure of a whole circle. If you have something that's in radian mode, and the way you know it's in radian mode is that it has a pi in it. You're either going to divide by 360 or 2 pi. Not both of them, one or the other, depending on what your angle measure is given to you, whether degree mode or radian mode. The other thing I need you to change is if you look at the circumference, it just says 2 pi, and actually that's not the circumference formula. It's actually 2 pi times r. So please change that so you know that you are calculating these correctly. So let us go ahead and try how to solve some of these. So the first thing says, find the length of the darkened arc. So again, we're looking for the arc measure. We do not know what that arc is, but we're going to use this formula. So what we're going to say is our arc is equal to, and I'm going to kind of use some colors here. Our arc measure is what we're going to put on the top. So our arc measure is this right here, this 315. All right, we know that's in degree mode. Since it's in degree mode, hopefully then, you know then you got to use that 360. I'm not going to use the 2 pi because what is above it is already in degree mode. So I want my degrees to be able to cancel each other out, divide out when we are simplifying later. The next thing is the other part of the equation. 2 pi and then times my radius. So remember that the radius is half of our diameter. It's from the center to one point of the circle, which in this case would be 11. All right, so now we have to simplify. So yes, you can kind of use your calculator, substitute everything in. I personally think it's best to do it in steps, just so that you know you are multiplying everything correctly. So what you could do is over here in our calculators, you can do that 315 divided by 360 to get an answer that's simplified. This is going to equal 7/8. And then when you're multiplying the 2 pi r, one thing to keep in mind is that you're going to treat that pi sign as kind of like a variable. You're not going to put it in your calculator. So really the only thing you're multiplying is 2 times 11, which is 22. So now to finally simplify your answer, you can take that 7/8 and you can multiply it by 22. We already have that 7/8 in our calculator, so actually I'm just going to go ahead and multiply it by 22. And that's going to give me 77 over 4, and I cannot forget to bring my pi down. So that is the measurement of my arc. Okay, let's try another one. So again, it says find the length of the darkened arc. I'm looking for my arc length, so therefore I do not know my arc. And again, I'm following this formula that's right above it. My arc measure. Now this time, my arc measure is in radian mode, right? This is my arc measure. This is what I'm going to be using. So my 3 pi over 2 is what is my arc measure. This is all on the top of my fraction. Now, when I'm dividing, again, like I said, if you are in radian mode, you're not going to use the 360. You're going to use this time, you're going to use 2 pi. And the reason is for that is because you want the pi's to divide out, so therefore you're going to divide by 2 pi. 2 pi and 360 is still referencing the whole circle, right? It's all the way around. So you're going to use whatever your arc measure is given to you, degree or radian mode. All right, we still got to multiply though by our circumference. So that's going to be 2 pi, and then our radius is 16. So again, always check to make sure that it's only half of, from the center to one point on the circle, so that is 16. Kind of running out of room there. And now we're going to simplify. So my arc is going to equal. What's nice is when you divide these fractions, if you do divide them by hand, having the pi on the top is actually going to divide the pi at the bottom. And then the 2's are going to combine together. So really this is going to be 3 over, and then you multiply 2 times 2, which is 4. If I lost you, yes, you can use your calculator and you can substitute everything in, and I will show you, and you must use parentheses. Always keeps everything where it needs to be. So if you want to even type in the pi, you can. You can say 3 pi divided by 2. That's one parentheses. And you want to divide the whole thing by 2 pi. Right? So again, I am putting the top in parentheses. I'm putting the bottom in parentheses just so my calculator can tell me exactly what it needs to be. And some of you are thinking, well, you put 3/4 and this told me 0.7. But if you actually divided 3/4, you would get 0.75, right? So it's still 0.75. It does not matter if you have the fraction or the decimal, they are equivalent. The next part is we're going to simplify our circumference there, 2 pi r. If you don't know what 2 times 16, you can just do the coefficients. Oop, I just pressed divide. 2 times 16, which is 32. We know this is going to be 32 pi. And now we're just going to further simplify. We know we had that 3/4. We're going to times that times 32. And that's going to give me 24 pi. So 24 pi is my final answer for my arc length. Alright, I'm going to scroll down a little bit, because now we have a scenario. Still going to use that same formula above. We just have to draw our own picture. So drawing our own picture here, it says in circle J. Okay, so we know we're going to have a circle. And that, excuse my not so nice circle. And I'm going to label it J because that's what it tells me. And it tells me that Km is the diameter. So I'm going to get a different color here. And it says Km is the diameter of 24. So diameter means it goes through the center. And this whole thing is 24. Alright, so knowing that the diameter is 24, that should kind of ring some bells. Because later on, we're only going to need the radius, right? Radius is half of that. So if you do 24 divided by 2, that's going to give us 12. So now we know that that 12 is actually the distance from here to here. That's going to be our radius, right? Because we just solved for that. Keep reading. It says, and the measurement of angle KJL. Well, actually, I made a mistake here because I never labeled my diameter. My diameter was Km, so I'm going to say my K is over here, and my M is over here. because now it's asking me to draw in another angle KJL. So if I go to K, right, I'm going to be at K, go to J, I need to draw L, and L is 120 degrees. Now, kind of just rough estimating here. If I go straight across, I know that's 180. If I go straight up, I know that's 90 degrees. So I'm going to draw my angle somewhere over here, because that means that this angle now is 120, which makes a little bit of sense, right? Because I don't want to go straight across, because that's 180. Straight up is a nice perpendicular, right angle there, so I don't want any of that. So we already did step 1. Draw our circle with all that given information. We have our diameter, we found our radius, even though it didn't ask us yet, and then we did label that angle KJL. Now it says find the length of arc KL. So what we're looking for is our arc of KL. This is what it's asking us for. So we don't know what our arc is, right? So our arc KL is going to be what we are solving for. Using that formula up above, right? The measure is what we put at the top. Well, our measure was 12. Or not 12, was 120 degrees. That was in degree mode, so therefore I'm going to divide that by 360 degrees. I then have to multiply it by our circumference, which is 2 pi, times our radius. Now our radius again is half the diameter, which we already solved for, and that was 12. So now we simply just simplify everything in our calculator. I'm going to kind of speed this up because you don't need to see me do it in the calculator. So we have our arc of KL is going to equal 120 divided by 360 is 1/3. 2 times 12 is 24. I can't forget to bring my pi down because I didn't, do anything with that, so don't forget to bring that down. And 1/3 times 24 is going to give me 8. Now, what's different from these examples than from the other ones is that the other ones, I guess I didn't think they had units. But I guess I was wrong. These all had units on them, and I just ignored them, apparently. So let me go back really quick and just pick a different color. Let's use orange. This one was in feet, so I should put feet. This one, our radius was measured also in feet, so this should also have feet. Our last example that I just did, it told us that this was measured in centimeters, so therefore this needs to be in centimeters. I apologize, I didn't know that those ones had units, but now we know. So there we go. So now we know that our arc length of KL is equal to 8 pi centimeters. And again, the reason why we leave the pi in there is because it tells us to leave it in terms of pi. If for any reason it tells you to round or be exact, all you have to do then in your calculator is multiply 8 times pi. Last couple examples here on the back side. Same kind of idea. We have to draw a scenario and we have to kind of use our formula to solve for our arc length. So in number 4, it says the windshield wiper of a car is 24 inches long. So kind of thinking of your car here, you have a windshield wiper. I'm just going to draw it like, going in the air. This is going to be 24 inches long. Then it says in one sweep, it turns an angle of 115. So this is going to technically move this way and sweep across, right? It's going to kind of go back and forth. Now they told us that this back and forth motion is 115 degrees. It says how far does the tip of the blade travel? So what we're trying to figure out here, tip of the blade is asking us what this arc is, right? We don't know what that is. That is what we're finding out is our arc length. So using the same formula as we did on the other page, we always start off with our measure. Our measure is 115, and that is in degrees, so I know I will be dividing by 360 and not 2 pi because it's not in radian mode. Times our circumference would be 2 pi. Our radius would be 24. Now some of you are like, well, why am I not going to take half? Well, the reason you're not going to take half is that technically to make a full circle, this would kind of be like my full circle this way, which means this line would go extended, which actually means that 24 is already my radius. My diameter would be double that. So we already have our radius. going ahead and simplifying this as fast as I can, 115 divided by 360 is 23 over 72. 23 over 72. 2 times 24 is going to be 48 pi. We then have this simplifying to be 46 over 3 pi. This was in inches. And it did not tell us to keep our answer in terms of pi, so I'm going to go ahead and simplify that in my calculator and say 36 pi divided by 3 is roughly about 48.17 inch. So it's about 48 inches that our blade is swiping back and forth. Example number 5. So it says a tire has a 14-inch radius. So if I draw my tire here, we know that from the center to my circle, this is 14 inches. That's my R. It says, what is the angle the wheel has rotated if the car moves 2 feet? Now, what's different is that what they gave us this time is actually what the car is rotating. Rotating means how many times it went around the circle. If it went around the circle, this tells me 2 feet. That actually is my arc. This is what the distance around the circle was. So I know that it's going to be, and I would also keep the 24 inches because our radius was measured in inches. So that's why we converted the 2 feet into inches. When we substitute into this equation, we know what our arc is this time, which is 24. My arc measure is what I'm looking for. We don't know what the angle rotated was. So this time, I'm going to put my x up here. I'm going to put my x up there, and then I'm going to divide by 2 pi. Okay, some of you are asking, well, why would I not use 360? The only reason why I'm not going to use the 360 is because when I multiply by the circumference, 2 pi times my radius, which is 14. What's nice is that I see that my 2 pi on the bottom and my 2 pi on the top are going to eventually divide out. So I'll kind of show you what I mean. So 24 equals. On the top, I have all of this because technically this is all over 1. So this is going to be x times 2 pi times 14 all over 2 pi, technically times 1, right? Now what we see is some things are going to divide each other out. Our 2 pi and 2 pi over each other, this part and this part, are going to divide and become 1. I am then left with 24 equaling x times 14, which would be 14x, still over 1. I'm not going to do anything with that because I don't need to put it over 1, but I still don't have my x together. Or alone, I mean. So this is getting multiplied. The opposite of multiplying is dividing. So I'm going to divide by 14 on both sides. This is going to give me x equaling 24 over 14. If you want to simplify that, all you got to do is 24 divided by 14. And that's going to give you 12 over 7. Now, this was in inches. And if you would like to put, if it doesn't tell you to approximate or to round, what you can do is you can change this into a decimal, which is about 1.71 inches. So about 1.7 inches. All right. So that brings us to the end of this video. Go ahead and work on the activity. Good luck.